So the function f is defined by f of x maps to 2 minus 2 cos of 4x for x values greater than minus pi over 2 less than or equal to pi, and is represented by the graph y equals 2 minus 2 cos of 4x. So part 4. Starting with the standard cosine graph y equals cos of x, outline a sequence of transformations that will map this graph to the graph y equals f of x. So starting with the graph of y equals cos of x. So I've drawn in blue the graph of y equals cos of x. And part 1, we're going to translate the graph a distance of 2 parallel to the y-axis to get the midway line of y equals 2. So basically we move 2 steps up. So we move 2 steps up, 1, 2. So now we have the graph y equals 2 plus cos of x. Step 2, we invert the graph about the midway line. So basically flip it upside down because of the minus. So since we have a minus 2, we flip it upside down. So again, the blue line is the graph y equals cos of x. And the red line is the graph of y equals 2 minus cos of x. So it's basically the graph of y equals cos of x flipped upside down, but also moved up 2 units. So the midway line is now y equals 2. Step 3, we stretch the graph vertically by a factor of 2 about the midway line. So remember, the midway line is y equals 2. So we need to bring our maximum points of our graph up as far as 4 on the y-axis. So go from 2 up to 4 from the midway line, up 2 to 4. And likewise, we go down from 2 down to 0. So our maximum point is now 4, our minimum point is now 0. So again, the blue line is the graph of y equals cos of x, and the red line is now the graph of y equals 2 minus 2 cos of x. So the range is now 0, 4 instead of 1, 3. So in the last slide, we saw that the graph was going up as far as 3 on the y-axis and 1 on the y-axis. So the maximum point was 3 and the minimum point was 1. Because remember, the midway line was still 2. And now the range is going up as far as 4, that's the maximum point, and down as far as 0, that's the minimum point. The fourth step, we want to shrink the graph horizontally by a factor of 4 about the y-axis. So remember, the period is always 2 pi divided by the number that's stuck on in front of the x, which in this case was 4. So 2 pi divided by 4 gave us pi over 2. And pi over 2 is here on our x-axis. So that's why we now have one period of the cosine graph going from 0 to pi over 2. But actually what's happening is the graph has been shrunk horizontally, so squashed in from left to right, squashed in horizontally, or shrunk horizontally by a factor of 4. But it ends up giving us a period of pi over 2. So if the number here stuck onto the x had been 6, for example, we would say it has shrunk horizontally by a factor of 6. If it was 8, we would say it was shrunk horizontally by a factor of 8, and so on. But remember, to work out the period, it's pi over 2 divided by that number. So this gives the graph of y equals 2 minus 2 cos of 4x. So here we have a summary of the steps that we just followed. So in the question itself, you were asked just to outline a sequence of transformations. You didn't actually have to draw out each step of the graph, but I just did that to show you step by step how we end up at 2 minus 2 cos of 4x. But the steps itself, the writing part, is enough. So part 5, use the graph y equals f of x to find all the solutions of the equation f of x equals 3 for x values greater or equal to minus pi over 2 less than or equal to pi. So by use the graph, they mean they want us to actually draw on the graph. So we want to find the solutions. So to solve the equation f of x equals 3, we draw the line y equals 3 and take the x coordinates from the points where the line cuts the graph. So here we have the graph, f of x, and here we have the line y equals 3. Notice that the line y equals 2 is drawn in as well, that's the midway line. So this is the line y equals 3. So what we do is we drop perpendiculars at all the points of intersection. Noticing that all the vertical lines on the grid below are separated by 15 degrees. So for example, this is the y-axis, so this is 0. And then we have pi over 2 up here, which we know is 90 degrees. And we notice that between 0 and 90 degrees, we have 1, 2, 3, 4, 5, 6 intervals. And 90 divided by 6 is going to be 15. So that means each of these lines represents 15 degrees. So if this is 15 degrees, add on 15 we get 30, add on 15 we get 45, add on 15 we get 60, add on 15 we get 75, add on 15 we get 90, and so on. So we can estimate the solutions for f of x equals 3. So as x is equal to minus 60 degrees, minus 60, we know that this is equal to minus pi over 3. As x is equal to minus 30 degrees, we know that this is equal to minus pi over 6. As x is equal to 30 degrees, we know that this is equal to pi over 6. As x is equal to 60 degrees, we know that this is equal to pi over 3. As x is equal to 120 degrees, we know that this is 2 pi over 3. And x is equal to 150 degrees, which is 5 pi over 6. So remember, the quick way to change degrees into radians, stick on pi and divide by 180.